As we begin Topic 4, let's go ahead and take a look at page 187 in your book. This is the page that allows us to get ready for Topic 4 and to review what you already know. Take a look first at the vocabulary section. Pause the video while you read each statement and choose the best term from the box to complete each definition. When you have finished questions 1 through 6, come back and check your answers. If you've made any mistakes, please correct your answers in your book. Okay, go ahead and check your answers to the vocabulary. Again, make any corrections as needed before you go on to the bottom half of the page. For questions 7 through 13, it's important that we review the order of operations. There used to be a sentence that a lot of teachers use to help students remember the order of operations. It went something like this. Please excuse my dear Aunt Sally. P, E, M, D, A, S. And here's what those letters stand for. The please stands for parentheses. E stands for exponents. M and D are multiplication and division, and those go in order from left to right. It's not always multiplication first, it's whichever comes first in the expression. And then the A stands for addition, and the S stands for subtraction. Again, in order from left to right, however it is that they appear in the expression. So please keep these order of operations in mind as you solve questions 7 through 9, especially. Those are all number-only terms. And then as you work on 10 through 13 at the bottom. So go ahead and pause the video while you do that, and then come back and check your answers. Please make sure that you show your work. Even though you have a calculator, you need to show your work so that you can see if you've made a mistake, where that mistake occurs. Go ahead and check 7, 8, and 9 before you move on to equivalent expressions in numbers 10, 11, and 12. All right, let's move on to 10, 11, and 12. In these three questions, you're going to be substituting values for A and B in each expression, and then use your order of operations to find the answer. Go ahead and pause the video while you try this, and then come back and check your work and your answers. You need to have work for each question, not just an answer. So please make sure that you write all your work, show all your work for each question. Go ahead and check number 10. Now go ahead and check number 11. And check number 12. When you finish checking and correcting any work or answers for all of the questions 1 through 12, take a look at number 13. On number 13, they don't ask you to actually evaluate, although you can do that as part of the process of explaining the difference between them. But you have two expressions here, and you're showing what is the difference when you evaluate each of them. So why are those two expressions not the same thing? By using the order of operations, you can see that these two will not yield the same result, because in the first expression, the order of operations tells us to multiply 3 times 7 first. In the second expression, 3 times 7 minus 4 in parentheses divided by 2 says that we need to subtract 7 minus 4 first. So since you're doing two completely separate operations first in each of these expressions, it's very unlikely that you will end up with the same result. And in fact, by following the order of operations, you next have to do 4 divided by 2, which results in 2, and then 21 take away 2, that subtraction is your last step, and you end up with an answer of 19. Now let's see what happens in the second expression when you have to subtract the 7 take away 4 first. In the second expression, after you have finished subtracting 7 minus 4, you get 3. But then you have those parentheses around the 3 and you see multiplication first. 3 times 3 divided by 2. So order of operations tells us to work from left to right. So we do 3 times 3 first, which is 9. And then 9 divided by 2 is 4.5. So this expression ends up being 4.5, while the first expression was 19. Now that we've done some practice with order of operations and evaluating expressions, we're going to move on to lesson number 1. Lesson 4.1, Write and Evaluate Algebraic Expressions. In this lesson, we will focus our attention on writing and evaluating algebraic expressions. Take a look first at the solve and discuss it. I would like for you to take these sticky notes, these yellow sticky notes on your paper, and see if you can sort them into 3 groups, showing which expressions you think are equal to each other. Mr. Ramirez's class was playing a game in which students need to match sticky notes that have equivalent expressions. How can you sort the expressions into groups? Again, your 3 groups need to show which expressions are equivalent to each other. See if you can do that and then come back and check your answer. All right, here are your 3 groups. At the top of the page, you'll notice that there are 3 expressions in each group. And each of these expressions, if you look down at the bottom of the column, I've shown you what each of those expressions in that group is equivalent to. So if you didn't get that, that's okay. Let's do a resort on your page so that you get those, you have those all sorted out. And then when you're done with that, go on to the next page for example 1. The essential question for this lesson states, how can algebraic expressions be used to represent and solve problems? In example 1, we're going to practice writing expressions to represent situations. An automatic dog feeder dispenses 2/5 cup of dog food each day. What expression can the dog owner use to determine the amount of food left in the feeder after D days? So you can see here from the picture that the dog feeder will hold, let me get my pen ready, there we go, will hold 20 cups of food. Each day, 2/5 of a cup is dispensed. So after 1 day, that's 2/5 of a cup. After 2 days, it would be twice that much. After 3 days, it would be 3 times that much, and so forth and so on. We can draw a bar diagram to represent the amount of food remaining in the feeder after D days, where 20, if you look down here at the bottom, underneath the picture, 20 is the total number of cups of dog food available. Okay? The feeder dispenses 2/5 of a cup every day. So 2/5 times D represents the food dispensed after however many days you're dispensing it. The amount that's remaining is what happens when we subtract that from the 20 cups, which is the total amount that the feeder holds. So using the bar diagram, the 20 represents 1 whole, and we're going to take away from that, or subtract, the 2/5 times D, which is the number of cups of food dispensed after however many days we are dispensing that food. So the dog owner can use the expression 20 minus 2/5 D to determine the amount of food left in the feeder after D days. Now we're going to try a similar question. Misumi started with $217 in her bank account. Okay, so underline important information. She deposits, okay, that means adds to her account, $25.50 each week and never withdraws any money. What expression can Misumi use to determine her account balance after W weeks? So we don't know how many weeks she's going to be saving money, but what we know is that every week she puts money in, it's $25.50. So when I do $25.50 times the number of weeks that she is saving, that will tell me how much money she has saved to that point. But what we can't forget about is that she had money in the account to start with. That's that initial deposit. So we start the account with the $217. Okay, so that's your starting amount. And then each week that she's saving money, we have to multiply that $25.50 times W. So here's the expression that Misumi can use to determine her account balance after however many weeks she is saving money. Don't forget that you're multiplying the $25.50 times W, which is the number of weeks that she is saving money for her account. In the Convince Me section, you'll notice that there are a couple of vocabulary words that we haven't discussed yet. One of those words is constant, and the other word is coefficient. So let's first talk about a constant. A constant number is just a number by itself. There's no variable. So this is a number only. There is no variable there. Oops, let me correct that. In this case, the constant is her initial deposit. That's the amount of money that she started with, and that is not changing. What is changing, though, is the amount of money that she is saving, and we call that the coefficient. So in this case, the coefficient is the number in front of the variable. For this problem, the number in front of the variable is that $25.50 because that number is going to change the amount of money in her account. And it's because we multiply it times the number of weeks that she is saving. So there are two vocabulary words that you'll be expected to know and use as we progress through topic 4. Now let's move on to example number 2.